So today we are discussing how to solve a rational equation. So a rational equation is simply an equation that has fractions, and usually it's called rational because we have variables in the denominator. So our goal here is to remove all the fractions so we end up with a regular equation. The general idea is because fraction bars are division, the thing we want to do is multiply to clear these. And what we want to multiply by is essentially a denominator. So on this one, this first fraction, and what I see is in my denominator, I have 2x squared minus 2x. One of the things I want to do first is factor it if it needs factoring. So I do have a GCF of 2x. If I pull that out, that leaves me with x minus 1. All right, so let's rewrite our problem with that new information. So I have x plus 5 over 2x times x minus 1 equal to 5 over x. So now what I'm going to do is multiply both sides by this denominator. The reason why I'm not worrying about x specifically, so I have 2 times x here, but this is also x. So essentially x as part of the denominator exists both in the second fraction on the right and also in the first fraction on the left. And it is multiplied in the denominator. So if I multiply by that, it should reduce out. So I'm going to multiply by, and remember to put in your parentheses for your quantities that you're multiplying. So x plus 5 is the quantity that's being divided, and 5 is the other quantity that's being divided. So 2x, x minus 1 on the first fraction on the left, 2x times x minus 1, second fraction on the right. On the first fraction, since I actually multiplied by the actual denominator, then 2x over x minus 1 divides out 2x over x minus 1, leaving me with the actual quantity of x plus 5. On the right-hand side, the only thing that actually will divide out is x. So x divided by quantity x is 1. That's going to leave me with 5 times 2 is 10 times x minus 1. Notice that I now have no fractions. So no fractions. Yay. Okay, that's what I want, because now it's just a regular looking equation and I can just solve it regularly. So distributing through on the 10, I'm going to get x plus 5 equals 10x minus 10. Variables on one side, numbers on the other. I'm going to get that by subtracting 10x both sides. And at the same time, I'm going to subtract 5 both sides. So I'm subtracting variables to the left and subtracting that, and numbers go off to the right. So on the left, x minus 10x, negative 9x. On the right, and then negative 15. And I chose to do it this way because then what happens is 5 minus 5 is 0, and 10 minus 10 is 0. So now I have numbers on the right and variables on the left. Last step, since it's negative 9x, then my last step is I need to divide both sides by negative 9. So now I have x equals 9 over 15. Oops, that's upside down. 15 over 9, sorry, because negative over negative is positive. And I can see that I can actually reduce out a factor of 3. So 15 divides by 3, 9 also divides by 3. So x equals 5/3. Okay. Something that you also need to do on these is check for restrictions. So restrictions, because I have variables running around in the denominator, I should know I cannot know division by 0. So I cannot do this. So I have to check to see where that happens. So I'm looking at this factored set here. I'm going to bring that over here to look at it. 2x times x minus 1. Where is that 0? Well, that's going to be when 2x is 0. That means x is 0. And x minus 1 is 0. That means x is 1. So that's where it equals 0. But what is my rule? This is not possible. So I don't want any x equals 0. This would be no. And I don't want any x equals 1. That would also be no. So I look at these numbers that I found, 0 and 1, and I look back at the solution I found, and I check to see if those match. They don't. So what I know is that that is okay. So that is a valid solution, and there is my answer. So this next problem, by the way, these are problems if you have my class. They are in, I believe most of them should be in the homework for 3.4, solving rational equations. So there's a couple solutions for you guys. All right, so this one is different because I have a subtraction. But the idea is the same. I want to multiply through, okay? So what I want to do is kind of look at my values. So I'm going to write this 2 as a fraction because I'm going to need to basically thinking about denominators. 1 over x minus x plus 1. 1 over, and then I want to factor that. So if factoring is possible, I look at x squared plus x. And I'm seeing a GCF of x. And then I also want to be considering my quantity, so adding in my parentheses. So the second fraction is 1 divided by x plus 1. So what I want to think about here is I have 3 fractions I'm dealing with. First fraction, second fraction, third fraction. And I have a minus. So when I am going to multiply, so I'm going to multiply by something, I need to distribute what I'm multiplying by. What I'm essentially wanting to multiply by is essentially the common denominator. And so basically the idea I'm doing here is to multiply through by the common denominator. And I can do that because it's equals. So I can multiply both sides, and then if I've chosen the correct common denominator, everything should reduce out. So what is my common denominator? I'm going to look at my set. I don't need to worry about the 1, but I do see that I have an x plus 1 factor. Anytime I have that factor, I only need it once for each unique set. So part of my common denominator is going to be x plus 1. And then when I look again, I'm also seeing this x. So that should be the other part of my common denominator. So I'm going to basically be using x times x plus 1. There's a couple different ways to approach this, but I find this one to be the best method for me and most of my students. So here I go. 2, I'm rewriting everything. Okay, one of the key things, when I am multiplying through, I need to multiply through every single term. So I have first term, first fraction, second fraction, everything split apart by minus or equals, and third fraction. So when I'm multiplying through, that common denominator should be multiplied 3 times. X times x plus 1 on the first fraction, x times x plus 1 on the second fraction, x times x plus 1 on the third fraction. Now all I need to do is reduce out things that are in common, things that reduce. So common factors. So on the first fraction, I don't have anything. Second fraction, x plus 1 over x plus 1. Last fraction, x plus 1 over x plus 1, and also x over x. So now everything's been crossed off of the denominators. The 1 doesn't matter because anything divided by 1 is what you started with. So now rewriting, I have 2x times x plus 1 minus 1x equals 1. Generally, you can do some of these problems together, but some of these steps together, but I just want to be clear. So now I'm just solving. What's my first step in solving? Distribute that 2x. 2x squared plus 2x minus 1x, and I see it's quadratic right here because of the x squared and the x. So I'm going to need everything to be equal to 0 in my next step. So I'm going to need to subtract that 1 off. So 2x squared plus x minus 1 equals 0. And now what I'm doing is either factoring or quadratic formula. Let's see, I'm looking for timesing to -2, adding to 1. So that's got to be 2 and -1. Okay, so factor set 2x, x. Normally you would need to do grouping or box, but if you want review on factoring, please review the factoring videos. So 2x and x. So let's see. I usually just quickly think about it. So 2x squared minus 2x plus x minus 1. So that's what goes through my head to make sure my factoring is correct. Okay. Equal to 0. So continuing to solve. That gives me 2x plus 1 equals 0. Subtract the 1, divide the 2. X equals -1/2. X minus 1 equals 0. X equals 1. So now what? Before I can say I'm done, I have to check restrictions. And essentially where I'm getting my restrictions, once again, is the common denominator. So that's what you're looking for the restrictions. So that's what I'm going to write over here to check. So I'm looking for where x times x plus 1 equals 0. That's going to be x equals 0, x equals -1. So these are my values that are not possible. So I check back here. So is -1/2 0 or -1? Nope, that's okay. That's valid. Is 1 0 or -1? Nope, that's okay. That's valid. So this particular problem actually has 2 valid solutions. Okay, this problem is the last one I'm going to do as an example. You can see that my level of complexity has kind of gone up on each one. So on this one, I have 3 fractions. It's addition. So it's an addition problem. And I'm looking for basically common denominators. If I look at my set, I have x plus 5, x minus 2, and then I have this. So on the last set, since that's got an x squared and an x, I'm looking at this and I'm thinking, yeah, I'm probably going to have to factor that before I can start figuring out my common denominator. So 3x over x plus 5 plus 1 over x minus 2 equals 7. Factor set of that, multiply to negative 10, add to 3, x minus 5, no, x plus 5, x minus 2. A comment on these, they're not trying to make your life too ridiculously difficult. So generally, if you have something like x plus 5 on one fraction and you have a factoring set, you'll probably also get an x plus 5 over here, because otherwise there's way too much factors running around in the problem and it becomes ridiculously difficult. So that can kind of help you figure out your factors. I'm kind of guessing the x plus 5 will be over here on the factoring set. I'm also guessing that x minus 2 will be over here. And when I started writing x minus 5, that was actually what I was thinking, is like, maybe that really should be x minus 5, because it shouldn't be like 10 different factors running around in the problem. Okay, as always, I should group my quantities, so I'm doing that now. Looking for the common denominator. Okay, all unique factors. So what I'm seeing is this factored into x plus 5x minus 2. So I know that's got to be part of the common denominator. So let's say x plus 5, x minus 2, and then let's check. Well, there's x plus 5, so that's already in the common denominator. And x minus 2 is already in the common denominator. So all the denominators I have in this set are in the common denominator. I'm checking. I don't have any other factors. So this is the value that I'm going to multiply through. So I'm going to rewrite it to be clear. I will say a lot of problems with these is you just need to be careful with what you're doing. There's a lot of math going on, a lot of algebra, and if you're messy in your work, then it's very likely that you'll mess up the problem. Multiplying through, I have three fractions, 1, 2, and 3. I know that because there's a plus sign, equal sign. So everything that's split apart by plus, minus, or equals is considered a separate fraction, and that's what I need to distribute through. So I'm distributing through both sides of this set. So x plus 5, x minus 2, x plus 5, x minus 2, x plus 5, x minus 2 on every fraction. I'm doing that because now my next step, reduce. So what can I reduce? On the first fraction, common factor of x plus 5 over x plus 5. Second fraction, common factor of x minus 2 over x minus 2. Third fraction, common factor of x plus 5, and also a common factor of x minus 2. So now, rewriting my next set. Again, it's pretty common for people to go ahead and sort of multiply through at this point, but just to be clear what I now have. So my first fraction turned into 3x times x minus 2. My second fraction is 1 times x plus 5. My third fraction reduced out a lot of the factors, so the only thing that's left over there is 7. Now I've got a regular equation, no fractions, so I just go ahead and continue. So just distribute to get rid of all the parentheses, multiply out. 3x squared minus 6x plus x plus 5x. Okay, wait. Okay, let's look at that for just a second. 1, 1. Okay, x plus 5. Like something didn't look quite right there, so that was almost a mistake, but I fixed it. And then 7. Okay. Again, I can see it's quadratic because I have an x squared and x in the same set. So that means factoring, quadratic formula. First step, simplify everything, get it equal to 0. So here's my like terms, and I'm going to move that 7 over. So subtracting the 7. So I'm going to have 3x squared minus 5x minus 2 equals 0. Okay, let's go with our factoring set. Times, multiply out to negative 6, add to negative 5. Negative 6 and 1 is my pair. So 3x and x minus 2 plus 1 equals 0. So 3x plus 1 equals 0. X equals negative 1/3. Subtract the 1, divide the 3. X minus 2 equals 0. Add the 2. These are my possibilities. What do I need to do to check? Take your common denominator, because that's what you check for your restrictions. So I need to know where x plus 5 times x minus 2 is equal to 0. That's x plus 5 equals 0, and x minus 2 equals 0. So my restrictions are x cannot be negative 5, and x cannot be 2. So I look at my first answer, negative 1/3. Is that negative 5 or 2? Nope. So that one is perfectly fine. That is a valid checked answer. Second answer of 2. Oh no, there's a 2. So x cannot be 2, but I found a solution of 2. What does that mean? Essentially, is this is invalid. So that one is not possible. So I have one solution of x equals negative 1/3, and that is the solution set for that problem. So basic process. Goal, first goal, get rid of the fractions. How do we do that? By multiplying by a denominator. Then, once we've done that, we reduce things. We then have a regular equation which we continue to solve. Then at the end, you must check at some point against the restrictions, because when you have fractions, you can generate values that don't work. So that's the end of how to solve rational equations.